So in this video, we're going to talk about the idea of mass percent and how would we calculate mass percent, okay? So I have a question here. It says that iron content in the earth is in the form of iron ore or ore, however you want to pronounce that. And common ones include, hematite, which is Fe2O3, or magnetite, which is Fe3O4, and saturite. So this is saturite. And saturite, which is FeCO3. Calculate the mass percent composition of iron in each of these iron ores, and which ore has the highest iron contents. Or however you want to pronounce that. Okay. And so the idea is which one contains the highest iron content. Well, we do this by mass percent. And so if I want to look at this, if I want to look at hematite first, okay, if I want to look at that one first, well, how do we calculate the mass percent of iron in this compound? Well, if I look at this, well, what's the total molecular weight of this compound? And so if I look at this, if I take a look at my periodic table, I'm going to multiply oxygen by 3 because we have 3 oxygens and 2 irons. Okay, so if I multiply oxygen by 3 and I multiply iron by 2, okay, and add those together, the total molar mass should be approximately 159.687 grams per mole. Okay, so this is the molar mass of hematite. Now, how much iron is in there? Well, I see 2 times iron. I see two iron atoms in this compound. And so if I look at this, I'm just going to simply multiply 2 times iron, 2 times 55.845. And when I do that, I should get approximately 111.69 because 55 plus 55 is 110 plus those decimals will approximately give me 111.69. And again, that's in grams per mole. So let me see. So this is grams per mole. That's in grams per mole. And I'm going to simply just multiply this by 100%. Notice that grams per mole is on the top, so they will eventually cancel out. So it just leaves me with percent. Okay. And so in this case, if I divide these two and multiply by 100, I'm going to get 69.943%. Okay. Now for magnetite, this is Fe3O4. Well, again, if I multiply 3 times 55, which is iron's, just pure iron's molar mass, that will give me 167.535 grams per mole of just iron. Okay. Now, what's the total molecular weight of Fe3O4? Well, if I do 4 times 16 plus 3 times 55, I should get a 231.531 grams per mole of Fe3O4. Okay, and I simply multiply this by 100%. Okay, and when I divide these two and multiply by 100%, I shall get around 72.360%. Okay, and then the last one, saturite, Fe3CO2. Well, because I have 1 iron, well, the molar mass of iron is just 55.845 from the periodic table, grams per mole of iron. Okay. I'm going to divide this by the total molar mass. So now I have a carbon, so I'm going to do 3 times 16 plus 12 plus 55. Okay, 0.845, and that will give me 115.853 grams per mole of FeCO3, and multiply this by 100%. Okay, and in this case, I will get approximately 48.23%. So you can definitely see that magnetite actually has the highest iron content. So what is the takeaway from this video? When we talk about mass percent, we always talk about the whole over some part multiplied by 100%. This is the general idea. So notice that the whole happens to be the whole compound. And if they're asking for just iron, well, we just took the part, which iron is just a part of the compound. We just single out how many iron atoms and look for the molar mass. And it's the same thing. What if they wanted to ask? What if they ask, well, what's the mass percent of oxygen? It would be the same thing. The whole numbers, all right. So the molecular weight of the actual compound wouldn't change. But what we change now is that we're looking for oxygen now. And so these molar masses at the top will actually change. And so this is a general idea of mass percent.